right, everyone. How are we doing today? Doing okay. Yeah, no, I have gotten reports from students in other classes that this is one of the weeks that people have decided to make lots of exams because in that other class I made an exam this Friday, so they're uh, squirming a bit under the pressure of that, and I forgot to ask what class it was. I think it's probably engineering class. It seems like there's a big uh, yeah. Well, that's how it goes. The It always seems like there's a couple weeks this second half of the semester where everyone has tests about the same time. I managed to miss the first window, which is like the end of September, which is the first time it all. Yeah, yeah. And, one of your classmates in the chat reports that statics and thermo is where they have some exams. So didn't know you could take those two classes at the same time. Thermo, they say. I didn't. Okay, well, back a long time ago when I was an engineering student, I didn't get far enough into the program to. I switched majors before getting around to taking thermo. Yeah, I think it was. I probably changed my major. Well, I changed things a couple of times. The first thing that I did was decide that I wanted to get a double major in physics and aerospace because I was an aerospace person. Um, and then 1 or 2 semesters after making that change, decided that it probably wasn't the best idea for me to major in engineering overall. So I ended up switching to just physics. So I definitely changed all the way before junior year. Okay. All right. The statics and thermo person has said that they're taking the classes later, not early. And for me, I basically took everything as early as possible. So that was why my recollection is out of sync. Uh, sorry, say that again. Oh yeah, the story with the online notes is I've gone kind of in a divergent direction from the person who's trying to change over the notes, and I was going to meet up with them and try to organize things between semesters to realign what we're doing. There are a couple of project type things that we'll have to finish up the semester, and those will have some more resources, a little less informal. But I need to decide exactly which of those I want to do, or if there are some things that I have to add to those before handing them out. All right. Oh, that is another thing that I'm sort of checking here in the background, is making sure that the server's working okay. At least my stream seems okay, and this so far seems to not be giving me trouble. I think it was just internet problems. There were some internal speed issues in the campus network because it was showing up in other places. All right. So today, let's talk about. I forgot to get out my writing implement. It's a problem when you have to get out 8 pieces of equipment. Sometimes you need the 9th and forget. That part's easier. Oops, come on. Okay. Huh? No, it didn't. Let's make the table taller. Just a little bit. Okay. So for advanced data types, there are in MATLAB 2 primary ones. One of these we've already introduced. And these are cell arrays. Okay. And for cell arrays, the main element that we have for this is that we're going to be using curly braces. Okay. Curly braces indicate to MATLAB that we're talking about these cell array structures. And what they allow us to do is collect many different types of data into one object. And I've introduced a couple of the basics about how these things are manipulated. And we can, we'll do a little bit more work with these later on, okay? The other ones I will introduce a little bit later on. I don't want to talk about these right now because the syntax associated with structures is more sophisticated, okay? But there is another advanced data type that allows us to, like we would use cell arrays for, have multiple data objects or types of data objects all collected in one place, and we interact with this system in a separate way. That is distinct from the way that we do most of our data type stuff in MATLAB. But before we get into that, I want to talk about the tools with respect to cell arrays. Okay. For a cell array, there are a couple of types of things that we can do. We can make a cell array. I can put a number here, okay? And the way that MATLAB sets this up is that it makes a matrix of cells, okay? Now, like we had with these other types of operations where we would do something like make a matrix, we can, of course, make this a one-dimensional object. And oftentimes when cell arrays are constructed, it is typically so that you would make them into a array as opposed to a cell matrix, okay, or a cell block if you want to have a punnier name for English. Okay. If I were to do something like have multiple quantities, like this, okay, and type in curly braces, and then in those have different types of data objects, the way that MATLAB tends to construct this is following the rules that are followed when we would build a matrix, okay, except here it's a cell array. I use commas to separate things the way that I've written it here. So I get a row of stuff. If I were to have used a semicolon, it turns it into a matrix. And of course, both of these are technically matrices. You can see the dimension here. All right. And MATLAB works to display them in a way that shows what's going on here. Okay. Now, one of the most powerful tools that involve cell arrays and require our knowledge of cell arrays in order to interact with them is something called var_argin. Okay? var_argin is a special data function in MATLAB that allows you to pass variably sized input lists to your functions. Okay? So let's say that I have an example where I want to be able to define a function handle that represents a piecewise function. So I have some function whose graph looks like this. So the question was, would this be some other way than to set it up using conditionals? Okay. We could write a function that has a bunch of conditions to set up this kind of structure. The thing is that if I wanted to change that to have a different piecewise function as opposed to the specific one that I'd drawn, I'd have to type in a bunch of stuff to change the way that was put together, right? I'd have to change the ranges on these values. Say this is 0 here. We'll say this is 2, this is 5, and this is 7. Okay? And of course, this is -1, 1, 2, and 3. Okay? I would like to define this piecewise function, but if I'm going to go to the trouble of writing a program to do this, I want to write it in a way to where it's relatively easy to change should I change the picture. Okay? So what I want to do is encode in the function this information. Okay? I'm going to make one small change to this just so that the program's a little bit easier to write to begin with. Okay. On the outer edges, it's going to be 0 so that we don't have to add a bunch of extra embroidery for setting things up. Okay. All right. So the way that this is going to be set up do this. Is we are going to utilize our var_argin function to build this. Sorry, I can't make up my mind if I want that to be F or Y. Huh? All right. Okay. So what I want to do is build the inputs for this so that they look like this. Var again has to be constructed. When var again is used, var again is intended to have some kind of structure that is understood by the program. And of course, that also means that it has to be understood by the user so that they know how to pass things in the proper format. Okay? There are two ways to do this, mainly. Number one, you just have a predefined structure for the way that var again is supposed to take inputs, a pattern. Okay? The other way is keywords. Okay? And you use the keywords to decode things, right? When we use things like the plot command, we would type stuff like line marker or line color or something like that, right? Those keywords, and then followed by a number or a vector, if it's a color that we're defining, would be part of that pattern, right? So MATLAB goes through and knows that it's looking for name value. When it sees the name, it matches up the name with what the value should look like, and then tries to make sense of it. If it can't, then it whines and gives you an error because you didn't give it the right kind of value for that name, or you gave it a name it doesn't recognize. It's the other thing that can go wrong. Okay, for us, what we're going to do is we are going to give var again so that it looks like this. Okay. It stands for interval. Okay, now this notation that I'm using is bad notation. Okay, the idea is that this gets pasted here. Okay, right? And what would be the normal list of inputs that our function would take? Except in this instance, we don't know how long that list of inputs is going to be exactly. We are allowing it to vary. So we use var again to absorb that variance. And MATLAB will absorb that into a cell array. Okay, var again is going to look like a cell array when we give it the inputs. But the inputs need to look like this. Okay, more specifically, they're going to need to look like the kth integer is going to be a vector that goes between two values. The kth value is just going to be some number. We'll put R for a real number. Okay. Now, of course, technically speaking, those numbers are different based on what interval it is we're discussing, right? Yes. Okay, so this will make sense when I start typing out an example, I believe, but just so that everything goes together. We refer back to this picture, right? Interval 1 is going to be the interval in this area here, right? So the idea is that it would be negative 2, 0. And the value is negative 1. Then we would have the interval from 0 to 2, and the value here is 2, and so on. Okay, so it's writing a list that describes these intervals as a vector, and then the numerical value that the piecewise function is supposed to take on. This is one of those things where there's a lot of syntax to get through before we get to an example, but I wanted to pick an example that was sophisticated enough where we actually have to use this tool to make the program work. Okay. All right. So what's going to happen is we're going to come up with a list of all these inputs that we want to pass to our program. Okay. And so the idea is that we say that f equals PCFun, which is just a shortened version of piecewise function. And we type in all this stuff. Okay. From negative 2 to 0, the value is supposed to be negative 1. From 0 to 2, the value is supposed to be 2. From 2 to 5, the value is supposed to be 1. And from 5 to 7, the function is supposed to be 0 according to our picture. And what we're going to do is, taking advantage of the way that the picture is drawn, if an interval is not specified, we're going to say the value is 0. Okay, so I'm going to leave 5 to 7 off the list on purpose. Okay, so the inputs to our function are going to look like this. Okay, now the point of the program is that we want it to be written in such a way to where this list can be of indeterminate size. I could have made it shorter. I could have made it have many more different pieces to it. Okay, but this is what the input structure is going to look like. And we want to write our code on the interior here in order to make all this work. Okay. Now, what we're about to do is one of the weird, tricky things that we can do in MATLAB. Okay. What I want to return is a function handle that is defined as this piecewise function. Okay. So I'm just going to make this a comment for now, but we can copy it later when we need it. We've defined function handles before to give us things like this, right? What I want to do when I'm finished writing this program is give me back an f that allows me to type in numbers to it and get the correct values. If I type in f of 2 for this picture, I should get 1, right? That's how I want this to work. Okay, so we need to build that here in MATLAB by constructing a subfunction or a nested function. We're going to use the nested function and use a special trick. Yeah. So What we're going to get as the output of this function is a function handle that if you give me as input the x value, it returns the corresponding y value that obeys this picture. Okay. All right. Now, we haven't done this semester, but what I'm constructing here is a nested function. In MATLAB, we are allowed to have nested functions and we are allowed to have subfunctions. We used subfunctions once very briefly previously in the semester. Okay, nested functions kind of work the same way, except they are defined in the body of the function itself. The reason that I'm doing this as a nested function, however, is that I can take advantage of a scoping exception. All right. You will notice that if you look at this, and it may be hard to see, but the text of Varigan has changed to a cyan color. Okay. This visual change, if you were to hover over it, is noted by MATLAB as saying that the Varigan here spans multiple functions. Okay. Normally when we have variables and functions, we write those variables in such a way so that each one exists in its own universe, right? If I pass variables to a function, I create a new workspace, and that workspace has those variables, is passed the values for those variables. Those values are associated with their own unique names inside of that function workspace, and then only the values that I deliberately return come back and are utilized outside of the function. Okay? Here, I need the information that is stored in Varigan in order for this function to work. That is where my intervals and the associated values are collected. Okay? This interior function is going to need that information as well. And what I'm about to do is construct a loop and a set of logical structures that navigate through the Varigan cell array to determine if I'm in a particular interval, and if I am, return the associated value, and if I match none of the intervals, send back 0. Okay? But that's what's going on here. This program will not work, however, unless we use this trick where, because this function is nested inside of this function, that it has access to Varigan. If I took this and put it down here, that is not cyan. And so I would have to pass as an extra input this Varigan value, but then things get complicated because I'd have to extract the values, assign them to a different name, pass them individually, and then parse that new data structure. And I don't want to deal with that. I just want to parse Varigan. Okay, so I'm using this trick in a way to cheat. All right. So what we're going to do is we are going to set y equal to 0 as a starting point because that's going to be our default value. That's what gets returned if nothing else happens. Huh? Well, I wanted to show the scoping exception. It'll come back. It'll come back. I just wanted to explain that all now instead of typing Varigan using more complicated syntax because we're going to have to work with Varigan before we get into that. Okay. So I've now typed Varigan again. We see that it's, whenever I type Varigan, it's going to have that cyan color to it. Varigan is supposed to have an interval and a value. Okay. Each of those intervals and values are stored as cells in a cell array. I take the length of Varigan, so that's going to give me the length of the total list. I cut it in half because I'm looking at these things 2 at a time. What I want to know is if the value x is within the interval that is being defined by Varigan. Okay? So the question that I'm going to ask is, if x is greater than or equal to, sorry, I need to make it into a loop. If Varigan is greater than or equal to the first entry of the kth cell of Varigan, and x is less than or equal to the second element of the kth cell, then we set y to be equal to sorry, I need this to be 2 times, this needs to be 2 times k minus 1 and 2 times k minus 1. And this is 2k. All right. This is what Varigan looks like, right? Okay. K I have set to go from 1 to n to match this, right? If I want to refer to this object, but I have to refer to the total array position relative to Varigan, I need 2k minus 1 for this to be 1 when k is equal to 1, right? And 2 times 1 is 2, which is why I need these to be written this way. It's just an indexing thing. I was getting ahead of myself and hadn't. There are ways to do it with respect to counting versus the whole array or counting towards counting by 2s. I set it up to count by 2, so I had to correct for that. Okay. And so the idea behind the program now is this part here, even though it looks a little bit complicated, is just checking to see if I'm within one of these intervals. Okay. And the way that the program is written, you should know this. If I have intervals that overlap, which we do, the interval that's counted is going to be the one that is stated latest in the list. Okay. Now, there are different ways that we could write the program to where it favors the beginning of the list as opposed to the end of the list, namely by just counting backwards, right? But when we set up our programs to do things like this, we need to be aware of the biases that are built into it. Okay. All right. So the idea now is that we check whether or not this thing works and then carefully go through it to see if it has the behavior that we intend for it to have. So if I pass it the set of inputs that we typed up earlier, it says that we have our object here. Okay. And what I'm going to do is I'm going to go in here now and put a breakpoint here so that if I say give the program the value -5, I should get 0 because -5 is outside of any of these intervals. Okay, so it jumps in. We see that the way that the program is set up, because the function handle points to this nested function, it jumps and is looking at this object here. We take a step, y is set to be equal to 0, and we have our x value here over on our workspace. We're going to go through. We're not going to reset y because we're in none of those intervals. Okay. We see that that's all going in there, right? And then also, this is what var again looks like inside of a program. It's just a cell array with all that stuff. So it grabs all that stuff and then puts it in a cell array because MATLAB has to have some vehicle to hold it, right? All of those things just can't exist as free-floating variable values. It has to be encapsulated in something. So the default thing that MATLAB uses in order to encapsulate these extra variables is this cell array structure. Okay, which is why these commands here have to use the cell array manipulations in order to parse this data. That's why I use curly braces and 2k minus 1 when k is equal to 1 to refer to this cell. It's the first cell. That's why we have curly braces here. And then the 1 is the first element. And I want to be larger than or equal to, greater than or equal to the first element, and then less than or equal to the second element to show that I'm within an interval. Okay. So we're continuing to step here. We're going to step out of the program. Hit continue. And the answer that we get returned is 0. Okay. If I type values that lie in the other intervals, after I remove that breakpoint so this doesn't pop up and get in our way each time, I get -1 for -1, which is what I should get. Right? If I type f of 0, I get 2 like I should. If I type f of 1, I get 2 like I should. If I type f of 3, I get 1 like I should. Right? If I type f of 6, which doesn't lie in any of our intervals, I get 0 because that's the default value for our function. All make sense? Okay. And so the last thing to set up with this would be to make it to where it works if I give it a vector of input values as opposed to just 1 and x at a time, right? The way that this is currently written is it fails if I try to pass it a vector. And that's really inconvenient, right? We should be able to rewrite this so that it works and I can pass it a list of input values for x or a vector of x values and then return the correct answer in each case. So for instance, if I wanted to plot my piecewise function, or at least come close to plotting my piecewise function to be able to do that, right? Putting this in a loop is not difficult at all. say, sorry, m equals the length of our vector x, for j equals 1 to m. Y, instead of being 0, is just going to be a 0 vector that has m zeros in it, and everything else stays the same, except this now needs to refer to the jth value of x, and this the jth value of y. And instead of trying to fix all that indentation by hand, we just use Smart Indent to sort all that out. Okay, so now we hope that this works for a whole vector of x values. So if I wanted to do something like set t equal to linspace that goes from -5 to 10 with, say, 150 values, and we redefine our function handle because I need to do that because I made changes to the way that the M file was written. I have to reassign this because it stores a bunch of information in memory behind the scenes. Okay, what I want to do is plot this. And it didn't work. Why didn't you work? All right. This is the debugging part. It gave me something that was the correct size. Okay. All right. For some reason, it returned all zeros. And it should here have given me 2 and 1 and 2 and 1 and 1, and it didn't do that. So we need to figure out what's causing the issue. It's only doing the last one for some reason. All right. Okay. So this is. Okay. Yeah. All right. This is probably the issue. Was that Y array was inside of the J loop instead of outside of it where it should have been. So We need to redefine this. Linspace is fine. Okay, there we go. Thank you for seeing that. Okay, so when MATLAB does plots, MATLAB connects the dots. That's its job, right? And so I made there be 150 points. So we see that there's some kind of diagonal lines here where the value jumps, right? Because MATLAB's not smart enough to know that it's supposed to skip those jumps. We can just chalk that up to small problems. But if we compare the picture that we see here to the picture that we see here, it does look like it's supposed to look, right? So we're getting the correct picture, all right? And the beauty in what we have done now is that we can define other piecewise functions of this ilk, okay, without having to go through and type in a bunch of extra details. All we have to do is structure the varargan input properly. So if I wanted to make a very simple function, say capital H, and this thing just looks like this, okay? I want it to be 0 outside of some interval, and I want it to be equal to 1 for some other interval. I went 0 to 1,000 because I really want it to be 1 for any positive x, but I'd have to do some more stuff in order to get that to work. But if I know all of my inputs are going to be less than 1,000, then this is fine. If I need a bigger number, I just pick a bigger number, right? And so what this would allow me to do is plot this function here. Okay. It is 0 up until 0, and then it jumps to 1 past 0. Okay. This function here is of particular use. It has a name. It's called the Heaviside function. Okay. And it is a common function that shows up in electronics applications. Okay. It gives us a mathematical way of representing whether or not something has been turned on. Right? What we do is we represent mathematically that the function has been activated at time 0, which is the way that the definition for this works. If I need to shift that activation time to, say, 2 seconds later, I use my horizontal shift rules from algebra. So instead of activating at 0, it now activates at 2. Okay. Now, for those of you who either have or have designs to take a class called differential equations, this will be something that you see again. Okay. Except you'll see it in the context of something called Laplace transforms, as opposed to here where we're using it as a numerical tool. Okay. And what this is really, really powerful for is if we want to do some kind of integration, we can use the Heaviside function as a way to turn off a function outside of a certain region, right? So say I have, how do I want to do this? Okay, sorry about the interruption there. I will have to see what's happened to the recording later on. Hopefully there's not too big of an issue there. Okay, so I was in the middle of trying to do some stuff with the Heaviside function. And what I wanted to demonstrate is, let's say we have some f that's equal to a function, and it is say 4 minus x squared. I may change this if I need to change it to make the values make more sense. Oops, but okay. All right. So okay, so we have this function here, and what we want to do is use Heaviside functions to control this object. Okay, what I want to do is I want to turn this thing off in particular regions. Say I want it to only be activated between -1 to 1 instead of, as it's pictured here, from -2 to 2. Okay? So the idea is if I integrate this from -2 to 2, I get this value in MATLAB, right? And if I were to integrate the function from -1 to 1, I get this value. Okay? Or if I were to integrate this from, say, 0 to 2, I would get this value. Okay? Our Heaviside function is set up so that if I give it a value that's less than 0, I get, or less than 0, I get 0, and if I give it a value that's greater than 0, I'm going to get 1. Okay? So what should happen is if I integrate f on the interval from 0 to 2, I get this value. And if I integrate the product of these two functions, it's not going to let me do this way. All right. Sorry, I forgot a dot. Okay, you're just not going to let me do this, are you? Okay. All right. Nope. MATLAB's internal computations are giving us trouble here. So what we should be able to do instead, okay, so we'll have to use the program that we wrote instead of the built-in MATLAB one in order to set this last demo up. If I integrate the function f, which is this parabolic shape on the interval from 0 to 2, so from here to here, we get this value, which is the one that we were getting when we used MATLAB's built-in routine. But what I really want to do is show that we can use the Heaviside function to allow us to control the interactions between our functions. So g is a function handle who has been defined so that the values that it generates are the product of the Heaviside function and the function f, which is our parabola. Okay. Why did that give me all those values? Did I forget to suppress something in here? Ooh. Why? This has got to be coming from a plot routine. It doesn't make any sense. Why are you giving me all these numbers? Why is it all wrong? Okay. Ugh. This is dumb. Okay. For some reason, G is not doing its job. Oh, I know why. That's annoying. Okay, nope, sorry, this is my fault. This doesn't work the way that I want it to. The way that, I'm sorry, I want to explain why this is an issue, just so it's clear what's going on and why what this seemingly simple thing does not operate in the manner that we think that it should. We made this vectorized, okay, so that when I have this type of statement, the thing that I'm getting out of this result is when I pass a vector worth of values. So it's doing a big multiplication where this returns a vector and then I do element-wise multiplication to this thing a bunch of different times instead of this being treated element-wise and this being treated element-wise, which is what I want. But I'd have to make the program I'd have to make this definition significantly more complicated in order to get it to do what I wanted. Because what I want is for the result for h of x just to be a vector of values and then multiply element-wise times this, where MATLAB goes through and does an implicit loop here. Anyway, okay. What I'll do instead is take advantage of MATLAB's built-in Heaviside function to show what I wanted to show. Okay. This is the picture that I wanted to generate from our function. It turns off the parabola prior to 0. Okay? And so if we integrate f from 0 to 2, integral from 0 to 2, this is the value that I get, right? And that's the same thing as if I integrate g, which is Heaviside times f, right? But the Heaviside function turns off f between for any value less than 0, right? So I get the same answer as if I were integrating from 0 to 2. So it allows me to turn off a function outside of the region where the Heaviside function is defined. If I want to shift the Heaviside function to change the interval that it is operating within, I can move it to the left, right? This is the same thing as me integrating on the interval from -1 to 2 now, because I shifted where the function turns on to be turning on -1 instead of turning on at 0. And if I need to turn on or turn off a function, what I can do is I can make a shift around a bunch of Heaviside functions, or 1 minus the Heaviside function if I need to turn off instead of turn on. Because if we plot t and 1 minus h of t, this starts turned on and then turns off at 0, right? So 1 minus h of t is the signal is on, turn it off version of this. And this is why this is so important from the perspective of electronics, because this represents switch flipping, turn on, turn off. And one of the things that you can do, for instance, is construct different types of waves and represent them mathematically. So one of the things that you may see that fits into the vein of these piecewise functions would be a square wave function. Okay? So you kind of get this castle wall pattern, right, of something that's turned on for some period of time and then turned off and then turned on. Okay. And you would also maybe see a sawtooth function that's used for EE purposes. Okay. Or regular old sine waves, which obviously are easier to represent mathematically than those other two. Okay. And if you've ever had to use an oscilloscope, all these different types of things are options that you can use as inputs to your system to figure out how the circuit behaves and all that. All right. So let's call it there. Sorry for the tech snafu in the middle there. And I will hopefully see what's going on with the video and see if I can stitch together the pieces of the recording from before the issue started. Take care, everybody. Have a good evening, and I will see you next time.